What if we could power our world with just water? Sounds like a dream, right? But it's not as far-fetched as you might think. Welcome to our deep dive into the science of hydrogen fuel cells. Imagine an energy source that's clean, efficient, and abundant. That's the promise of hydrogen fuel cells. Hydrogen is the most abundant element in the universe and a key component of water, the life-giving liquid that covers over 70% of our planet. When we harness hydrogen for energy, the only byproduct is water vapor, making it a clean, sustainable energy source. Hydrogen fuel cells have the potential to revolutionize our energy production, powering everything from cars to homes and even entire cities. They could reduce our reliance on fossil fuels, cut down on carbon emissions, and help us build a sustainable future. Intrigued? Let's delve into the science behind this incredible technology. Hydrogen fuel cells work like batteries, but they don't run down or need recharging. They use hydrogen and oxygen to produce electricity with water and heat as the only byproducts. To understand the magic of hydrogen fuel cells, let's break it down. Picture a sandwich, but instead of bread and filling, you have a positive electrode or anode, a negative electrode or cathode, and an electrolyte membrane in the middle. This structure is the heart of a hydrogen fuel cell. Here's where the science gets fun. Hydrogen gas is fed into the anode, where it splits into protons and electrons. The protons pass through the electrolyte membrane, but the electrons are forced to take a longer route, creating an electric current. Meanwhile, oxygen enters the cathode, where it combines with the electrons and protons to produce water. This water is then expelled from the cell, leaving behind electricity and a bit of heat. What's fantastic about this process is that it's clean and efficient. There's no combustion, meaning no harmful emissions. The only byproducts are water and heat. Imagine that, an energy source where the only waste is water. But let's not forget about the efficiency. Conventional power plants convert about a third of the energy in fossil fuels into usable electricity. Hydrogen fuel cells, however, can reach efficiencies of up to 60%. And when the heat they produce is used as well, these efficiencies can climb up to 85%. But wait, there's more. Unlike batteries, which need to be recharged after they run out of juice, fuel cells keep producing electricity as long as there's a supply of hydrogen and oxygen. They're like the Energizer Bunny of energy sources. To top it all off, fuel cells are quiet, require less maintenance than traditional engines, and can be used in a wide range of applications, from powering electric vehicles to providing electricity for homes and businesses. So we are essentially turning water into energy, and the only waste product is water itself. Sounds perfect, doesn't it? Hydrogen fuel cells aren't just a concept. They're here and they're already powering a variety of applications. This isn't just a theoretical idea, but a practical reality that's transforming our world as we speak. Let's take a closer look at some of these applications. In the realm of transportation, hydrogen fuel cells are making their mark. They power cars, buses, and even trains, offering a cleaner and more efficient alternative to traditional fossil fuels. For instance, take the example of Toyota Mirai, a hydrogen fuel cell vehicle that emits nothing but water. Or consider the Alstom Coradia Island, the world's first passenger train, powered by a hydrogen fuel cell. But the potential of hydrogen fuel cells extends far beyond the transportation sector. They're also used in stationary power applications. For example, some power plants have begun to integrate hydrogen fuel cells to generate electricity. They offer a reliable and efficient source of power even in remote areas. Let's not forget about portable applications either. From powering military equipment to providing energy for outdoor recreational activities, hydrogen fuel cells are showing their versatility. One such example is the EFOI Comfort, a portable fuel cell that can power a small camper for weeks on a single tank of fuel. What's more, hydrogen fuel cells are also being used in space. They've been a critical component of NASA's space program for decades, providing power for the spacecraft and clean drinking water for the astronauts. These examples only scratch the surface of what hydrogen fuel cells can do. Every day, new applications are being discovered and explored, from powering drones to providing backup power for data centers. And it's not just about the practical applications. Hydrogen fuel cells also have the potential to significantly reduce our greenhouse gas emissions, helping us combat climate change and create a more sustainable future. With such diverse applications, hydrogen fuel cells could truly revolutionize our energy landscape. This isn't a distant dream, but a reality that's taking shape right now. And the best part? We're only just beginning to tap into the vast potential of this extraordinary technology. But what does this mean for our future? Could hydrogen fuel cells be the key to a clean, sustainable energy future? As our global energy demands escalate, we search for solutions that are not only efficient and reliable, but also environmentally friendly. Hydrogen fuel cells are promising candidates in this quest for clean energy. Powering everything from cars to homes, these cells offer a carbon-free alternative to traditional energy sources. Hydrogen fuel cells are more than just a concept. They're already in use today, powering space missions and electric vehicles. Imagine a world where every home, every car, every device is powered by clean energy from hydrogen fuel cells. A future where our energy demands are met without compromising the health of our planet. However, as with all great innovations, there are challenges to overcome. One of the primary hurdles is infrastructure. Today, our world is designed around fossil fuels. Gas stations, power plants, pipelines, these are all built to support an energy system based on coal, oil, and natural gas. Transitioning to a hydrogen-based system would require significant changes to this infrastructure. Another challenge lies in the production of hydrogen itself. Currently, most hydrogen is produced from natural gas, a process that releases carbon dioxide into the atmosphere. To truly harness the power of hydrogen for clean energy, we need to find more sustainable methods of production. Solar and wind power, for instance, could be used to split water into hydrogen and oxygen, a process known as electrolysis. Despite these challenges, the potential of hydrogen fuel cells is enormous. They offer a viable solution to our global energy problems, providing a sustainable, efficient, and clean alternative to fossil fuels. As we continue to innovate and improve, the dream of a hydrogen-powered future becomes more and more plausible. While there are hurdles to overcome, the potential of hydrogen fuel cells to power our future is undeniable.